Hi, my name is NUR AZRINA Binti Zaini. I would like to present my final year project. The title is Smart Hydroponic System using Internet of Things. For this presentation, we have 5 topics include, which is introduction, literature review, methodology, result, and conclusion. Okay, first of all, what is hydroponic system? Hydroponic system is one of technique for growing plant without using soil. Okay, hydroponic require less space than plant grow in soil, which is depend on the system. When hydroponic are combined with vertical farming technique, they can use up to 70% less than typical farming techniques. Second, use minimum water. Growing plant in water, you actually use more water than growing the same plant in soil. In fact, hydroponic plants can grow with up to 70% less water than traditional growing method. Third is prevent pests and disease. Logically, pests and disease come from soil. So, by using hydroponic system, no soil is used and pests and disease can be prevented. Okay, for hydroponic system, the nutrient film technique have been used, which is this system have two components, which is grow tray and the reservoir. Which is the reservoir is to store the water and nutrient solution. The reservoir contains a nutrient solution to provide to the plant. The pump in the reservoir will pump the water to the plant tray, and the water will flow each plant and return back to the reservoir. Okay, the advantage of NFT is easy to inspect root for a sign of disease due to absence of medium. Second, low water and nutrient use, and easy to disinfect roots. Okay, since 2020, Malaysia become one of country that facing COVID-19 infection. So, since that situation, Malaysia imposed a movement control order, which is MCO, on everyone, including farmers, and they are not allowed to farm manage their crops. So, this system is suitable to the farmers since they are not allowed to go to the farm. Second, some users have small and limited space and have difficult to take care of plant. So by using this system, it can help them to monitor the suitable nutrient solution that depends on their plant. So the objective of this project is first to design a smart hydroponic system, which is we had used the ESP32 TTGO LORA and some of sensors such as pressure sensor, TDS sensor and DH222 sensor. Second, to develop a hydroponic system that can send measured data by using LoRa technology to the ThingSpeak platform. Third is to evaluate the performance of plant growth when applied this smart hydroponic system from cloud platform and mobile apps. Okay, there are some of existing project, and this is more related with this project. First paper is monitor and control the parameter during process plant growth. Second, control the system through Blink application, and they had used the LCD display. The advantage of this project is they have limited range. Second paper is they monitor the plant growth process, the nutrient solution and air humidity temperature automatically, and they can monitor the condition using the web monitor. So the advantage of this project is they have limited range, which is they only use the ESP8266 and no apps related in smartphone. And third paper is monitor the quality of water by using web technology, and this paper is use solar power to operate the system. So the advantage of this project, they have limited range since they use ESP8266, high cost since they use the solar power. Okay, for this project we have two parts, which is front end and back end. Front end consists transmitter module and a few of sensor, for example pressure sensor, TDS sensor, DH222 and DS18B20. And for the back end part, we have receiver module, we have cloud platform, and we have mobile apps. Okay, first of all, the sensor will measure the condition of water and send the data collected to the transmitter module. Okay, from the transmitter module, the data will be sent to the receiver module by using LoRa. And from the receiver module, The data will be stored in the cloud platform, which is we use ThingSpeak by using Wi-Fi connection, and the data will be displayed to the user. Okay, in this project, we had used MIT Inventor platform, which is this platform is online platform that used to design mobile application by using block language. Okay, for MIT Inventor, there are two parts, which is designer part and block editor part. Okay, for designer part is used to design how app will be look like, which is we can add button, we can add image, label, the speaker, notifier, and so on. So this is one of main screen for this mobile app for this system. Okay, this is the block editor part. Block editor part is used to design how app will look alike. Okay, for example, in main screen there are 4 button, which is current button, data graph, more info, and out button. So for at block editor part, we will assign which screen that will be appear after the button is clicked. For example, when current reading is clicked, the screen 9 will be appear. Okay, in this project, there are some of individual experiment. Okay, first, measurement of water pump flow rate. Okay, this experiment is used to observe the volume of water when pump A and pump B on based on time. In this project, we use two pump, which is pump A for fertilizer A and pump B is for fertilizer B. Okay, from the graph, which is it shows the average volume of water based on pump A and pump B, and it can be concluded that the longer the time, the higher the volume of water that be collected. And as you can see, the flow rate of water is about 1.6 ml per second. Okay, next experiment is the accuracy of TDS and pH value. The objective of the experiment is to observe the accuracy of TDS and pH value based on volume of fertilizer AB for 6 liter water. And this is the graph that shown the comparison between TDS value for digital meter and analog sensor. For the experiment, we had used TDS meter and TDS sensor. Okay, from the graph, it can be seen that the volume of TDS value for TDS meter and TDS sensor is directly proportional to volume of fertilizer AB with accuracy error about 2.7%. And we can conclude that 1 ppm is about 45.553 ml fertilizer AB. Okay, this is the comparison between for pH value between digital meter and analog sensor. It can be seen that the higher the volume of solution AB, the value of pH is decreased, and the accuracy between the pH sensor and pH meter is about 2.98%. Okay, next experiment is height of plant testing. The objective of this experiment is to observe manually the height of plant, TDS, and pH value for 40 days. Okay, for the right picture, it shows the hydroponic set with the water tank, and for the left picture, it shows the plant after 40 days. Okay, this is the graph about the graph for height of plant versus day. As you can see, the height of plant quite slowly increase between day 1 until day 22, but it increased rapidly from day 22 until day 44, and the standard TDS value had been used is 1580 ppm, and the pH value is 5.8 value per pH. Okay, next experiment is measurement of saturation time of AB solution mixing. Okay, this experiment is to measure the saturation time of AB solution mixing after add 25 ml of solution AB during main pump off and main pump on. Okay, from the data had been collected from the previous experiment, the expected value for 25 ml of fertilizer B and A, the TDS is about 1363.85 ppm. Okay, this is the average for TDS value when main pump is off. There are 100 data collected for every 3 second for 3 second data, and as you can see, it can be concluded that the TDS value takes more than 5 minutes to get the expected value because it increase slowly. Okay, this is the average data for the TDS value when main pump is on, and it be conclude that the TDS value had been rapidly increased and started stable after 1 minute 5 seconds, which is about 1380 ppm. Okay, next experiment is measurement of pH reading when pH up and pH down added. Okay, the objective of this testing is to observe how affected pH up and pH down solution to the pH value. Okay, this is the graph for pH value based on volume of pH up, and it can be seen the average of 1 ml pH up is about 0.3, and for this is the graph for pH down, which is about 0.4. The average for 1 ml pH down is about 0.4. Okay, next experiment is performance of LoRa communication for different location. Okay, this experiment is used to observe the smart hydroponic system fully running for a few days based on data obtained at testing part before put the different location for receiver module. Okay, this is the for the left picture, it show the set of the hydroponic, and for the right picture is about the system for this hydroponic system. Okay, for this experiment we have 3 conditions, which is condition A is put the receiver module at room, second put the receiver module at the backyard area, and the third is receiver module at living room. Okay, as you can see, this is the graph for TDS and pH value for location A. As you can see, the data had not been complete received since the distance between the room and the hydroponic system is quite far, but not far because they have some block wall between them. So second location is the receiver at backyard area. As you can see, the data also not receive everything since they have the error in internet Wi-Fi connection since the place is at the backyard area. So next is receiver module at living room. As you can see, the data have been completely received for the receiver module since the distance between the living room and the hydroponic is not very far, and the Wi-Fi connection is good since the Wi-Fi is available in the house. Okay, next experiment is actual performance of smart hydroponic system. This is the TDS value for 3 days full testing for hydroponic system TDS value, and this is the pH value. As you can see, the TDS value for 3 days have been dropped at 6:20 p.m. which is 0 ppm, while the pH value is about 2.4 pH. So this is because the water level at that time is low, so the sensor are not able read the data correctly. Okay, the last experiment is develop the mobile app for the smart hydroponic system, which is to observe the operation of user app for this smart hydroponic system. Okay, as you can see, this is the screen for the mobile app, which is at the picture at the left is about the main screen, and at the left at the right picture is about the when the more info button is clicked, so it will be appear like that. So this is the screen when the current reading button had been clicked. So for figure 16 show the water level, which is when the LED green is on, it means the water level is high. If the LED red is on, it means the water level is low. And the others reading, it will be appear like the figure 17, which it will be appear the data. Okay, this is the screen when the data graph button is clicked. So as we can see, we have in figure 18, it shows the button for each data. For example, if we click the temperature data button, it will be appear like figure 19, which is the previous data collected for the temperature. So, the conclusion for this project is this project was successfully developed and achieved the objective by having some series of experiments that have been carried out. Second, the result able to achieve the same with the expectation result. And third, the system is able to successfully operate based on flowchart, which is the data collected from sensor able to send to the mobile apps by using LoRa and Wi-Fi connection. Okay, the recommendation for future work is 1. In terms of user app, this app can be improvised from monitor apps to control apps. Second, for accuracy aspect, the TDS and P value reading can be improved by using different of type water pump instead using the same pump. And third, apply this system for a few plants such as lettuce, strawberry and tomato. So that's all. Thank you.